Alrighty, continuing on with our frictions. Friction worksheet. A block of mass M slides down a ramp with a constant speed. Oh, that's important. Um, due to kinetic friction. The angle is theta. Find all the answers in terms of these symbols. Uh-oh, you can't use numbers. I know it hurts, but you don't need to use numbers. Draw a free body diagram of the block. Well, I just happen to have the block sitting on an incline right here, and the force of gravity acting on its center of mass points straight down to the earth. Doesn't go off to an angle, straight down to the earth. Force normal is perpendicular to the surface, so it is straight up at a right angle to the surface. It's a contact force, which is why I drew it all the way down to the surface. Force of friction, if this thing is trying to slide downward, that's what it said. I don't think it's going to go up. Then the force of friction has to be parallel to the surface and opposing motion, so the opposite of motion. They told me it was kinetic because I'm sliding. Draw a free body diagram on the block. Okay, this is where my x-axis is. This is my x-axis. This is my y-axis. So I'm coming down over here and I'm going to draw it in the XY plane that I'm used to seeing. That's my recommend. Force normal straight up the Y. Force of friction, I'm not sure why I keep coughing. Force of friction is to the left, kinetic friction. I just got to add my force of gravity. And so this is the one that's wonky. So get your piece of paper, turn it sideways, see which direction it's off to the right at some weird, funky angle. And we'll come down to that in just a minute. There's my official free body diagram. There is nothing wrong with that right there. Okay. Now, was I perfect in making sure my links are all the same magnitudes? No. And they 90.9% of the time are not, they don't care. They will every once in a while make you draw it to scale. I have a visitor. I will be right back. All right, back to where we were at. I just want to include a couple things. I know that acceleration is equal to 0, and it's v is constant. It is actually still sliding down that ramp, but I have an acceleration equal to 0. So that's important because I need to use that fact as I solve some things. Okay, I want to know what is the acceleration of the block. Didn't they just tell me it's 0? Yeah, so that's actually pretty easy to answer, hopefully, but maybe not actually. Acceleration is equal to 0 because my speed was constant. Okay. C, find the force normal acting on the block. So I'm actually going to come over here and redraw this so I can mess up my free body diagram, because you cannot mess up your official free body diagram on an AP Physics exam. Force of kinetic friction. Now I'm going to draw some components. So this is the angle up top of the incline, and I'm going to draw force of gravity down times, oh, it's adjacent to that angle, which is cosine of theta. And there is my y reflection of force of gravity. So that's force of gravity times the sine of that angle. Okay, because that's the opposite side. That would be right here, picked up and moved. And I can do that because, well, vectors, doesn't matter where the origin is, as long as the same length and the same direction, and that is the case. Okay, C, force normal. So force normal, I have to sum all the forces in the y direction. How many forces do I have in the y direction? I've got one here. I've got another one there. I've got 2 forces in the y direction. So I got to sum all the forces in the y direction. Force in the y is equal to mass times acceleration in the y. I know it looks like a G. I've been scolded by my daughter. Okay, and force normal goes up and subtract force of gravity. Well, what's FG, guys? FG is equal to mg, which is the same as the weight. In the y direction, if I go back over here and look at my thing, my graph or my box, it's got the y going straight through the center of mass up force normal. It's not accelerating. It's sitting there at 0. So 0 equals force normal. Oh, by the way, shame on Mrs. Query. It's not FG, it's FG cosine theta. Whew, everybody was starting to freak out right about now. I could feel it. Force normal minus FG cosine theta is equal to 0. So I know force normal is equal to FG cosine theta. That is equal to, well, I have the mass mg cosine theta. Force normal. Now, are all those things allowed? Yes, there is my answer with the units that, or with the variables that they allow. D, find, what is the coefficient of kinetic friction between the block and the incline? Okay, let's go and look at that. That's over here. Okay, that's in the y direction. So let's sum the forces in the y direction. Sum the forces in the, I'm sorry, x equals mass times acceleration in the x, which is equal to, well, which one is positive? So this one is my positive force. This one's in the opposite direction. So I'm going to subtract that one. So I have FG sine theta minus force of kinetic friction. What's the definition of force of kinetic friction? Mu K times force normal. Huh. Well, I just found force normal, so let's add that in. Oh, by the way, what is the acceleration in the x direction? 0. Okay. So all I'm gonna do is I'm going to rewrite this equation and accept that I'm gonna plug into force of kinetic friction the values mu K times force normal, which we just found to be mg cosine theta. This is force normal. Okay, so I get 0 is equal to force times gravity, or sorry, force of gravity, which is mg, so that's allowed, times sine of theta, that's allowed, minus, now I'm going to do a substitution here, mu k times mg cosine of theta. I'm trying to find mu k, that's what they asked for, coefficient of kinetic friction. Now all I have to do is solve for the variable that they want. So the first thing I'm going to do is add, subtract mg sine theta on both sides, minus mg, yes, I know, mg sine theta from both sides. Now I'm going to subdivide by mg cosine theta. Actually, I'm going to divide by the negative. And I will get mu k is equal to, and notice what happens to mg. Cancels. Anyone know what sine theta over cosine theta equals? Tangent theta. This is perfectly fine to leave, but this, if you know your trig functions, is correct. Let me go double check. Yes. Now that's crazy, isn't it? It is crazy. If you can increase the angle of a ramp to get it to the point where the force of friction is equivalent to the force of gravity times the sine of theta, then you can find experimentally the coefficient of kinetic friction. Ah, there's a lab for you. Okay. They're like, whatever, that's freaking me out.